Hello. The task of this project is to recognize named entities from sentences with a multitask neural network. The project is modified from a previous task. Here are the information about it. The inputs of this project should be in the format of Cornell 2012. It only needs words from sentences, the words part of speech tags and the words entity tags, and pre-trained embeddings. And the output tuple is the word with its target entity tag and the predicted entity tag. Here is the overall structure of the network. There are two tasks in the network to train the model. The one is entity segmentation task, which to identify whether a word is an entity or not, and the other is the entity classification task. Given a sentence, firstly, it learns each word's character feature with a convolutional neural network, word feature with a bidirectional LSTM, and lexicon feature with a dense network. When the three features are encoded, they will be combined and passed to a common dense neural network. This network will be trained with two tasks. In addition to classify the entity classes with the neural network, to exploit the sequential information of the sentences, the weights of the neural network will be passed to a conditional random field classifier to predict the entity's class. Based on the author's result and my experiments, the result from the CRF classifier is always better than the neural network. Here are the datasets. I used WNAT17, a dataset from the third workshop on noisy user-generated text, including 6 classes, and Cornell 2003 OnToNoise dataset. These 3 datasets cover the general topics. The first dataset I use is Caminar, a biomedical data with 8 classes. Here are my evaluation methods and the results of this project. I use precision, recall, and F1 score to measure the performance, and the overall result is the Markov average of all classes. Let's move to the demo part. In this demo, the window to capture the sequential information is set as 3, and the embeddings to encode the word feature is a Twitter pre-trained embedding. I also set other parameters here. To save time, the epoch number is saved to 5. The embeddings can be downloaded from the website, and here is the reference. Firstly, the project imports required packages. The model is built with TensorFlow. Then it loads data. The project receives the path of data files and pre-processed data. The acceptable format of the project is Cornell 2012. However, the trainer only needs words part of speech tags, and the entity tags. In this demo, I use Cornell 2003 dataset. After loading data, the categories will be printed. The pre-trained embeddings will be loaded here as well. This project uses 2 embeddings. Now, the block encodes the orthographic, word and lexicon features and the labels. This project builds the neural network in the train function. The inputs are the captured features before, and there are 2 tasks used to train the neural network. The network information will be printed here. And we can see that the loss and accuracy during training will be printed. To same time, I will speed up here. After training, the model will be saved to the defined path. This prediction block predicts the named entities for test words. It uses the neural network and the conditional random field classifier to generate predictions, and the predictions will be saved in the output file. The format of the output file is a tuple includes the word target tag, and the predicted tag. Here is the evaluation block. The predicted results will be printed, including precision, recall, F1 score, support, and confusion metrics. we can see that the CRF classifier have better performance than the NN classifier. The loss during training is printed here.